In this video, we're going to look at two common multi-step calculations that can come up in the molecules and matter unit. So we're going to do a quick recap of a couple of key concepts, and then I'm going to go over two example questions. So the first concept is all to do with heating. And we know that if we have a temperature time graph for a substance, it looks like this. So in these two regions here, we have a change of state. So in this one, we have melting or freezing. And in this one here, we have vaporization or condensation. We obviously have solid, liquid, and gas. In these three regions here, then we are heating or we're cooling, depending on which way we're going. And like I said, this is a solid, liquid, and a gas. So the first one is all to do with heating. Actually, no, so I'm not going to write heating. It's not the best word to use. I'm going to put a change in temperature. Heating is, of course, when we add energy. But when we add energy, it can do two things. It can either increase the temperature or it can change the state. So for a change in temperature, we need to use this equation here, which is given to you. So energy transfer equals mass times specific heat capacity times the temperature change. So in symbols, E equals mc delta T. This means temperature change. If we want to write this out to work out a mass, for example, we would write mass is energy divided by specific heat capacity times temperature change, or we could write heat capacity is energy over mass times temperature change, or even temperature change is energy over mass times heat capacity. And you are expected to be able to rearrange it for these. The second concept is a change in state. So we're looking at these regions here, and the energy transfer or the energy required for a change of state is equal to the mass times the latent heat. So latent heat is the energy to change 1 kilogram of substance. Now, if it's the latent heat of vaporization, that means it's going liquid to gas or gas to liquid. And if it's the latent heat of fusion, then it's going solid to liquid or liquid to solid. So obviously melting or freezing, vaporization is condensing, or vaporization or boiling. And again, in symbols, this equation becomes E equals m. Sometimes it's change in mass times L for latent heat, and that's really easy to rearrange. The change in mass is energy over latent heat, or the latent heat is energy over mass. So what this means is when we have a change in state, some energy is required or some energy is given out. So if, for example, we are going solid to liquid, well, we know that we have to put energy in to the substance. So we might say we're heating it. If we were going, for example, gas to liquid, then effectively energy is released. Okay, it's the gas is transferring energy away from it, and that's released. And this is really important to remember, and equally the opposite, because if you have questions where, for example, they ask you about why sweating is important, well, it takes energy to change the liquid sweat to gaseous sweat or to water vapor. Where does that energy come from? It comes from your blood and your body, and therefore that cools you down. So really important ideas here. Let's look at two different example questions. So number one, it says a kettle is filled with 800 grams of water and brought to a boil. The power of the kettle is 1.5 kilowatts. The specific heat capacity of water is 4,200 joules per kilogram per degree Celsius. How long does it take to boil? So when we've got a question like this, there's two steps to it. So we're being asked for a time. And what other information do we have? We have power is 1.5 kilowatts, but we don't want it in kilowatts, we want it in watts. So it's always a good idea straight away to change it into watts. And if you write it like this, you may even just get a mark for doing this. We also have mass, which is 800 grams. And again, we don't want it in grams, we want it in kilograms. So a good idea to write it down, change it straight away. We also have heat capacity, which is 4,200 joules per kilogram per degree Celsius. So what are we going to do? Well, we need to recognize that the equation that has heat capacity in is energy equals mc delta T. But we don't have energy, we have power and time. So step one is actually to use power is energy over time and then rearrange for energy. So power times time is energy. So therefore, 1,500 watts times by our time is our energy. I should have rearranged it first, shouldn't I? I should have said time, sorry. Time is energy over power. So time is energy over 1,500 watts. How do I get my energy? Well, I need to use this equation here. Energy is mc delta T. So our energy required is 0.8 kilograms times by our specific heat capacity times by the temperature change. So what is the temperature change? Well, we actually don't know here, do we? The question should have said. So that's my fault when I wrote out this question. I forgot to write this out. So it should have said water at, 20 degrees Celsius, right? And if they will always tell you that in a properly written question. So our temperature change is our boiling temperature, which is obviously 100. And again, sometimes they'll write it like that to try and catch you out. Minus 20 degrees. So therefore I can put that in my calculator. And get 268,800 joules. And now I can put this in this equation up here. So our time is 268,800 divided by our power, which is 1,500 watts. And that gives us a time of 179 seconds, or 179.2 seconds. So this will be worth probably 5, maybe 6 marks. Okay, let's look at the other kind of question that you would get. And it says something like this. A volume of 3.0 times 10 to the minus 5 meters cubed of water condenses. Density of water is 1,000 kilograms per meter cubed. Specific latent heat of vaporization of water is 2.26 times 10 to the 6 joules per kilogram. Calculate the energy released when the condensation forms. So again, we've been given volume, we've been given density, we've been given latent heat of vaporization, and we want energy released. So the equation that has energy and latent heat in is energy is mass times latent heat. But actually, do we have the mass? We don't have the mass, we have the density and the volume. So you need to remember that density equals mass divided by volume, or in symbols, rho is m over v. So therefore, mass equals density times volume, which is 1,000 times by 3.0 times 10 to the minus 5, which is 3.0 times 10 to the minus 2 meters cubed. Now we can put it in this equation. So energy is our mass times our latent heat. So we can then type that in our calculator. And this is obviously also a test of you being able to use standard form. And that gets us 67,800 joules.